Welcome to the Astrodynamics.com, theastro.com. Hi, I am Jim De. I am an Astrodynamics algorithm co-developer. This video is to address two important missing topics of astrodynamics. First, the missing source codes and practical numerical examples of astrodynamics algorithms. Second, the missing commercial space catalog. A space catalog is the address book or position data of objects around the Earth. These are some of the excellent textbooks of astrodynamics. My book complements these textbooks with source codes of fundamental and advanced astrodynamic algorithms in Fortran, C, or MATLAB, and over 100 practical numerical examples. Coding the equations of theories is much more complicated in the real world, and that's why the source codes of astrodynamic algorithms are missing in most textbooks. This is no knock to other excellent textbooks. My book may help a student to ace a course or shorten the learning curve of a master's or PhD thesis topic of astrodynamics, orbital and celestial mechanics. Also, over 100 real-world numerical examples may help practicing engineers and scientists to develop new ideas and insights to solve today's problems. The commercial space catalog has been missing for decades, and rarely anyone talks about it. Again, a space catalog is the address book of fast-moving space objects around the Earth. If the space objects in the two constellations are cataloged, their motion or orbits or position data can be computed as displayed in this picture. There are many satellites and space junks flying at great speeds around the Earth, as in this picture. The more cataloged space objects, the more complete the space catalog. Shows about 60,000 space objects in the US space catalog after over 60 years of cataloging, or on average about 1,000 cataloged space objects per year. This pace of cataloging has been sufficient for about 50 years until the rapid use of small satellites from SpaceX, OneWeb, Amazon, and many other countries came about a decade ago, starting around 2010. Starlink proposed 42,000 small satellites for global internet connections. Will it take 42 years to catalog the Starlink satellites? No, because they are US satellites and their orbits are known, and therefore the Starlink satellites can be tracked, cataloged, and maintained by the US. It took a long time, maybe 6 decades, for someone to understand or admit that the US cataloging astrodynamic algorithms are mainly for catalog maintenance of known or cataloged space objects. This is no knock to these excellent catalog maintenance algorithms that focus on box 1, correlate observations as indicated by the blue arrow. Astrodynamic algorithms for unknown or uncatalogued targets, UCTs for short, are their weaknesses as indicated by the broken line and the red arrow. Space catalog building algorithms can process known and unknown space objects, or UCTs, while catalog maintenance algorithms are designed to process only known space objects. If EU, Russia, and China follow the Starlink lead, like building their own GPS systems, there will be over 100,000 new small satellites in the near future, and these non-US objects start off as UCTs. They greatly increase the difficulty of space situation awareness, or SSA, and therefore most of the commercial satellites are and will be flying blind. Also, they greatly increase the chance of space collisions, the cost of space debris cleanup, or even space operation insurance, among others. Rapid space catalog building require analytic astrodynamic algorithms that can rapidly process UCTs. This is why my book provides the source codes of 7 analytic Windy-based catalog building algorithms to process efficiently the UCTs. Today, in 2022, space operations cost roughly 500 billion US dollars per year, and commercial space businesses are growing rapidly. A commercial space catalog is the missing link between almost all space operations. This is the gold mine that nobody is talking about. The 1970s is the golden age of astrodynamics because of the Apollo and the Space Shuttle projects. I had the great fortune to get into MIT in 1974. Started my master's and PhD theses under scientist Ted Atterbaum, but finished under Professor Dick Patton in 1978. My MIT PhD degree is in astrodynamics. If you missed the opportunity to learn from my MIT teachers, Atterbaum, Patton, Wendell and Winty, you may, with hard work, hopefully learn something from my book. This book includes concise theories, key equations, and source codes in Fortran, C, or MATLAB, plus over 100 practical numerical examples. Thank you for watching this video of the Astro.com.